I want to take a few seconds to talk about the differences between mean, median, and mode, and when you might use one, now that we've kind of talked about skewed data sets. So here we have three different things. This one at the top. This is a symmetric distribution, and this one has a left skew. Sometimes they call the skews tails. That's kind of an easier way to remember what is a left skew. It's kind of like it has a left tail. This is a right skew, meaning its tail kind of goes to the right. Basically, the reason you might pick between three different things is you can kind of start looking at if you actually start calculating some of the different what actually different numbers are. In general, if you have something that is symmetric like this, the mean or the median is really the best thing to use, because it usually is pretty close to the middle, and the mode is also usually pretty good too. If it's symmetric like this, pretty much any three of these really work very well to describe what's going on. You start running into problems, though, when you have things that are skewed one way or the other. Now, if we zoom in, we'll just use this one as an example. You can kind of see what's going on here. Now, the first thing is, actually, this is a little bit hard to see. So the mode is actually this one, the median is actually this one, and the mean is this one. So if you look at this, it looks like most things that are happening, like the most stuff is right. I mean, this is going to be in this area. Most everything is right here. So if you use the mean or the median, you're actually getting kind of far away from where most of your information is. We have a lot of people that are right in this area, and as we go this direction, there is less, there's less people doing something, or there's less whatever it is. Now, since you have lots of things down here, or we might consider these to be outliers down in this direction, what you end up doing is you end up slowly moving the mean and the median down towards this way. If you have lots of outliers, you end up shifting the mean towards the outliers because you're bringing the average down or up. And the median usually moves down as well. So sometimes, like in this case, I might say that the mode actually represents most of the data the best. Let's look at another example with something we made, or I made. So here I have a simple dot plot, and what we can do is we can kind of look at this and figure out, which thing is the best, which actually represents where most of the information is. Let's say that this was a quiz that was worth 10 points, and we want to see, how did most people do, or what was is the average the best, is the mode the best? What are we going to do? So one thing we can do is we can solve for all three of them. Obviously the mode is 9, right? Because there's the most 9s. The median is going to be, if I started counting some of these, I have 4 here. So if I take 4 off, 1, 2, 3, 4, 1, 2, 2. It looks like my my median would be 1, 2, 3, 4. It would be about 8.5. And so I'm kind of doing that mentally, looking at this. But if I listed all these numbers out, 1, 1, 1, 2, 7, 8, 9, 9, 9, 9, 9, 9, 10, it would be 8.5. Okay, so those are actually pretty close. And then we could figure out the mean. Let's take a second and calculate the mean. So if I add everything up, I notice I have 5 9s, and 9 times 5 is 45, and 7 plus 8 is 15. So this would be a total of 60 if I'm adding these together, plus that would be 70, and plus 3 plus 2 would be 75. So the mean would be 75 divided by 12. That actually gets us 6.25. So you can see with this set of information, we have really different things going on. We can definitely see how most people are up in the 7, 8, 9, 10 area. But there were a couple people that really didn't do so great. These might even be considered outliers, just because there's less of them. Now, if you see something like this isn't a great example of outliers because there's actually, 4 people down here, which is about a third of them. But still, most of the people are up here. So if you consider these to be outliers, these 4 people down here are skewing your mean to be much lower. It's right here. This is your mean in here. But there's really nothing here. There's these really low numbers, then everyone else is pretty good. So in this case, the median or the mode would probably be better to use for some cases, just because they're more representative of what's going on with most people. Now, let's just say, for example, that we got rid of all these numbers down here. Let's just say these numbers did not exist. So we only had these guys up here. Now, how would that change everything? Well, in that case, our mode would still be 9. Our median would be 9 as well. This would change to be 9. And the mean would actually become 70 divided by 8, which would be 8.75. This would be the new mean. So you can see with this, if we get rid of all these outliers down here, we actually brought our mean up a lot. Now, we didn't change the mode at all, and we also barely changed the median. In this case, I would actually say that the mean is actually a pretty good measure because we do have mostly 9s, but we only have 1 10 up here, and then there's 2 numbers below 9. So I would say maybe maybe a good measure is slightly under 9, and I think that the mode works best in this case. So you really have to be careful when you're interpreting things, just to look at how things are set up and look for outliers, and keep in mind that outliers will always bring your medians and especially your mean. It'll start changing those a lot more. So you kind of have to look at things and determine whether or not you want to use the mean, median, or the mode, depending on what information you have, and which will represent your data the best way that you want it to.